Hello students, today we're going to discuss JEE Main 2025 questions from chapter Units and Dimension, January attempt, that is attempt number 1. So we divided this chapter into two parts. Today we're going to see the first part. And we have a page in Instagram and WhatsApp group. Do join in group to explore more regarding physics, especially competitive examination. And also don't forget to subscribe our channel to watch more video like this. So let us start with the questions. We'll see the first question, statement 1. In a vernier caliper, one vernier scale division is always smaller than one main scale division. So to check this condition, we'll take an example of standard vernier caliper. It's a main scale division and down to that it's a vernier scale. So you can check on the main scale, each division represents 1 millimeter. So we can write it as 1 MSD is equal to 1 mm. And same way in the case of vernier scale, each division represents 0.9 millimeter. So we can write it as 1 VSD is equal to 0.9 millimeter. So from the value we can check that vernier scale is always lesser than main scale division. So first statement is correct. Okay. Then we'll go for the second statement. The vernier constant. Vernier constant means it's a least count. So least count is given by one main scale division multiplied by number of vernier scale division. It's an incorrect statement because to find the least count, we have two formula. So first formula is 1 MSD minus 1 VSD, and second formula, least count is equal to 1 MSD, that is main scale division, divided by number of vernier scale division, which is capital N. So it's divided by, but here they have given it as multiple by, so it's an incorrect statement. So we can check the option. So statement 1 is true, statement 2 is false. Say option 2 is the right answer. Next question, if B is magnetic field and mu naught is permeability of free space, then the dimension of B by mu naught. So to handle this question, we need a formula that contains magnetic field and permeability in free space. So here I am going to choose the formula that is magnetic field at the center of a circular coil. The formula is B is equal to mu naught I by 2R. Okay, so in the question they have asked B by mu naught. So because of that, I am going to take mu naught to the opposite side. So B by mu naught is equal to I by 2R. So now we'll substitute the dimension formula. So for current, we can write it as ampere. But 2 is a constant, so we can neglect that one. Radius comes under length. Okay, so we can take length to the numerator. So it will become L power minus 1 and A power 1. So we'll check the option. Option 2 is the right answer. The maximum percentage error in the measurement of a density of a wire. So they asked propagation of error for density. So they have given mass, radius and length. With respect to that, we'll choose the formula. So the formula density is equal to mass by volume. In the place of volume, we can substitute area of cross section in length. Okay. So since they have given radius, we can expand area of cross section. So mass by area of cross section of a wire by r square into length. So for this equation, we have to write propagation of error. So in the place of density, we can substitute del D by D, that is equal to mass del M by M. I is constant, so we can neglect that. Balance, in the place of R square, we can substitute 2 del R by R, and for length del L by L. So they have asked in the form of percentage, so we can multiply 100 on both the sides. So 100, and here also it will be 100. Okay, now we can substitute the value. So they have given mass M and 0.003 is del M. Again this is R and del R, length L and del L. So we can substitute the value in the place of del M, 0.003 by mass 0.6 plus 2 into del R is 0.01 by 0.5 plus del L 0.05 by 10 into 100. Okay, so now we will calculate the value. So we can cancel in third table. So you will get the answer as 0.01 by 2 plus 0.2 by 5 plus 0.005 into 100. Okay, so again we can calculate. So here you will get it as 0.005 plus 0.04 plus 0.005 into 100. So if you sum up means you will get the answer as 0.05 into 100, that is equal to 5%. So we'll check the option. Option B is the right answer. The dimension formula for capacitance. So to find the dimension formula for capacitance, we have to choose the formula which contains capacitance. So here I am going to take the formula charge is equal to C into V. So first we have to find the dimension for charge and potential difference. Then we can substitute in this formula. Okay. So first to find the dimension formula for charge, we can take basic formula. Current is equal to charge by time. So charge Q is equal to I into T. In the place of current, we can substitute ampere, and for time it's capital T. Okay, and to find the dimension for the potential difference, we can take the formula from electrostatics, that is work is equal to charge into potential difference. The potential difference V is equal to work by charge, that is equal to, in the place of work, we know the dimension formula, that is m L square T power minus 2, and for charge I into T, or in the place of I we can substitute A. Both are right. So here we can substitute A. So now we can reform the dimension formula. So it's m L square T power minus 3 A power minus 1. Okay, so this is the dimension formula for potential difference. Now we can substitute in this equation. So C is equal to Q by V. In the place of Q, that is A into T. In the place of potential difference, m L square T power minus 3 A power minus 1. Okay, so that is equal to m power minus 1 L power minus 2 T power plus 4 and A power 2. Okay, so we'll check the option. Option 3 is the right answer. The energy of a system is given by E is equal to alpha power 3 E power minus beta T. So where T is a time, they have given the value for beta. The error in the measurement of alpha and T, they have given it as 1.2% and 1.6%. The question is, at time T is equal to 5 seconds, maximum percentage error in the energy. Okay, so to find the maximum error, first we have to expand the equation of energy. So E is equal to alpha power 3 E power minus beta T. Okay, so first we'll take ln on both the sides. So ln energy E, that is equal to 3 into ln alpha, again minus beta T. Okay, so here we need maximum error. So we can differentiate. So del E by E, that is equal to 3 into del alpha by alpha minus beta. T will become dt, that is 1 dt, but we need in the form of percentage. So I'm gonna multiple and divide by T. Okay, and also they asked maximum percentage error in the form of percentage. So I'm gonna substitute 100 on both the sides. Is it okay? And most important, always in the case of error, we should not substitute minus. Always we will add the error. Because of that, this minus will become plus. Now we will substitute the value. So 3 into del alpha by alpha, they have given in the form of percentage. So that is 1.2 percentage plus beta is 0.3 into del T by T is 1.6 percentage, and we have to substitute the time. Time they have given it as 5, so into 5. Okay, if we calculate this value means we will get it as 6 percentage. Option 3 is the right answer. Next question, we have to find the dimension formula for following quantity. So first we'll start with easy one, magnetic field. To find the dimension formula of the magnetic field, here I'm going to take Lorentz force. So Lorentz force F is equal to QVB sine theta. We can neglect the sine theta because it's a trigonometry function. So balance magnetic field is equal to F by QV. Okay, so now we'll substitute the dimension formula for force mLT power minus 2. For charge, it's ampere into time. So that we have seen in the previous problem. In the place of velocity, we can substitute LT power minus 1. Is it okay? So now we can cancel length. So balance and T, my T power minus 1 will get cancelled. Balance M T power minus 2 A power minus 1. So magnetic field matches with second one. Okay. So next we have to find permeability in free space. So for that, I'm going to take the formula, that is B is equal to mu naught I by 2R, that is magnetic field for the circular coil at the center. So here we have to find the mu naught. So mu naught is equal to 2RB by I. Okay, so we can neglect the constant 2. Balance the place of radius length L and magnetic field M T power minus 2 A power minus 1. And for the current, ampere A. Okay, so we can take A to the numerator. So mu naught is equal to m l t power minus 2 A power minus 2. Okay, so now we can see the permeability in free space matches with 3. And next, magnetic moment. So for magnetic moment, we can take M is equal to NIA, where N is a number of turns, we can neglect that. For the current, we can take ampere. And for area, it's meter square, that means L square. So we can see magnetic moment matches with 4. And last one, torsional constant. So to find the torsional constant, we can take formula of the current sensitivity. Theta by I is equal to NAB by K, where K is a torsional constant, or else you can take one more formula, that is torque is equal to K into theta. We can take this formula also. So here theta is the angle, so we don't want to take this. So the torsional constant is equal to tau. So tau means that is moment of force, torque. So that is equal to, it's a direct formula, because for all the type of energy, work and torque, we have same dimension formula, that is ml square t power minus 2. So last D matches with 1. Okay, now we can check the option A matches with 3. So from that itself we can tell, so option 4 is the right answer. Next question, the position of a particle moving on x-axis is given by x is equal to a sin t plus b cos square t plus c t square plus d, where t is a time. They are asking the dimension of ABC by ds. So in the equation, all the term has the same dimension. So this is first term, a sin theta is second, this third term, c t square is fourth, and d is fifth. All the term has the same dimension. So first one, a position comes under length. So first term has a dimension of length. So rest of the terms also has the dimension of length only. So we can substitute this in second term. So second term, a sin t, that is equal to, the dimension of second term also has to be L only. So in the case of sin t, it's a trigonometry function. So we don't want to take that. So the dimension of A has to be length. So same way we can see for the third term. So third term is B cos square theta, that is equal to, the dimension has to be length. So cos square theta is, again it's a trigonometry function, we can neglect this one. So the dimension of B also has to be L. And again fourth term. So for fourth term, it's C t square, that is equal to, the dimension has to be L. So C, it's t square, that is equal to L. If you are taking t square to the opposite side, means C equal to L t power minus 2. And balance fifth term, it's D. The dimension has to be equal to L. Okay, so now we have found the dimension for A, B, C and D. Now we can substitute in this equation. So the equation A, B, C by D is equal to, in the place of A length, B also length, C is L t power minus 2, and in the place of D again it is L. So we can cancel this both. Balance you have L square and t power minus 2. So we check the option. Option 3 is the right answer. The energy E and momentum P of a moving body of mass m are related by some equation. Given that C represents speed of light, identify the correct equation. Okay, so mainly this equation from Einstein equation, that is E is equal to mc square, and from energy of a photon, E is equal to p square. So using these two equation, we can find the correct equation. So you can check the option. All the equations are in the form of E square. So if it's E square means E square is equal to, this will become m square and this will become c power 4. And here also it will be E square is equal to p square and c square. So using this format, we can check the formula. You can see option number 4, E square is equal to p square c square and m square c power 4. And all the three terms will have a same dimension. So option 4 is the right answer. Okay students, we came to end of this session. So if you have any doubts or queries regarding this video, please comment it. And to watch more video like this, don't forget to subscribe the channel. Thank you students.